Alright guys, so this is your helpful hint video for your FRQ practice, Friday, August 16th. We're working on FRQ, year 2014, questions 1A and B, and on FRQ, year 2015, question 2C. Remember, the way that you guys should be doing these, if you want to get the most out of it, is to try it on your own first. Then watch my video if you got stuck, then try it some more, and then finally go on YouTube and type in the year and the number, emphasizing Calc AB FRQ, and you should be able to find the video. You have to fast forward to the particular part you're interested in. FRQs have a bunch of parts. You only want to focus on the parts that are of interest. After that, you should really go also on the internet, Google, and search for the scoring guide for that particular question to see how the grading is done. And as you can see, that's about 25 minutes for one FRQ piece that I'm assigning you. I'm giving you 2 this weekend. That's a total of 50 minutes, unless you put off the other one also until now. And now you've got about 75 minutes worth of FRQs to do plus the homework. Sorry, it's a lot, but this is a tough class, and I told you we're going to have a lot of homework. So hopefully you guys don't wait till Sunday night for this. Let's go ahead and get started. So with this question, I'm feeling like part A should be fine. You guys should have no issue with part A. The reason being, my helpful hint video for the last FRQ I assigned is exactly like this. So there's really nothing for me to add there. But part B, I'm going to go ahead and help you out with there. I'm going to help you out with 3 things on part B. On part B, first of all, I'm going to help you guys out with the derivative. That's one thing you guys are going to probably need help with. We did it in class today. It's a calculator question. So if you don't have your calculators yet, you're going to have to get one on the internet or go buy one because you're going to need it. So you're going to need to have your calculator to get the derivative. Another thing that I'll help you out with on this today is helping you adjust the window of your calculator in order to see what you're trying to do. Because sometimes when you graph something, it's not on the window. And of course, once again, units come up here, and we don't really get into the whole units thing. We did on the last one. We don't really get into that until like unit 5 of our year, but it's not that bad, so I'll show you what it is, and we'll go ahead and do it. So remember, I'm not doing this problem for you. I'm going to do something that helps you with those things. All right, so I will use the same function that they have, though, because I'm just that kind of guy. I'm a nice guy. So here's the function they give us on this particular FRQ. Okay, and they're asking us to find a prime of 15. Now, the part that I'm going to do different, though, is I'm going to do a prime of 20 instead. Okay, just because I want you guys to do the other one on your own. All right, the way that we're going to do this is we're going to go ahead and go to y equals, right? We're going to type in our function, 6.687 parentheses 0.931 to the power of x. Then you're going to look at your graph. And then we got to find the derivative. However, you're going to find something interesting happens here if you tried to do what we did in class today. I'll show you. What we learned in class today was you push second, calc, push 6 for the derivative, and then you type in your x value, which the one I'm trying to find right now is 20. So I would type in 20 and equals, and it says error. Now the reason it says that is because I'm going to go back to my graph. Actually, I have to push second and quit now, and then I go back to my graph. The reason why is because look at my window. It only goes from up to positive 10. And I'm asking my calculator to tell me about something that is at x equals 20. That's off the screen, and if it's off the screen, my calculator is not going to cooperate with me. So I have to be able to see more of my screen in order to get that. So what I'm going to do is I'm going to change my viewing window so I could see all the way out over here where x equals 20. So I'm going to push window. Now you see where it says x min, x max, y min, y max. That means my current screen goes from -10 to +10 for the x-axis, and for the y-axis it goes from -10 to +10. Now I want an x value of 20. Now I'm not going to take my y max to 20 because I want more than 20 so I can see a little bit more in my graph. So I'm going to put 25. Okay, now I'm going to go back to my graph and notice the screen looks different because now it's going to show me all the x values out to about 25. Okay, now we can go ahead and do the derivative. So second calc 6, and now I'm going to type in 20 equals, and there's my derivative. Now you want to remember that when you write down your answers, you want to give 3 decimal places. Okay? So it would be 0.1, I already forgot it, I gotta look again. 0.114 is my slope. Now they also mentioned something about units. They mentioned something about units. Now you guys remember from the first FRQ helpful hint video that I gave you, let's just say that A represented airplanes and T represented time, right? Let's say hours. Okay, so airplanes is the output, hours is the input. Well, when you usually do slope, right, it's y2 minus y1 over x2 minus x1. So it's the outputs over the inputs. So what we have on the top is we have airplanes, and what we have on the bottom is hours. And so our units for the slope would be airplanes per hour, right? I'm just making up weird units. You can ignore that. But the point is airplanes per hour. Well, instantaneous rate of change, remember, that's a slope. So even though I'm not calculating slope this way, instead I'm using a derivative, it would still be output over input. So in this case, it's airplanes per hour also. Okay, so that's the units. So we talked about 3 things here. How do you find the derivative on a calculator with adjusting the window screen? That's the second thing, adjusting the window screen. So we had to see where 20 was at. And then we talked about units. Those are the 3 things that I feel like you'll probably need help with. All right. So that's the end of the helpful hint video for FRQ 2014, number 1B. Let's go ahead and move on to doing our helpful hints for FRQ 2015, question 2C. Okay. Let's take a look at the problem here. So we have 2 graphs here, okay? One on top of the other. We have this, let me get my pen. We have this line here, and then we have this line here. There's 2 lines, right? Now the question is saying, let H be the vertical distance between those 2 graphs in the region S. So we're looking at this region here, and we're going to let H represent the distance between those. Okay? They're asking us to find the rate at which H is changing with respect to X. The rate at which H is changing with respect to X, dH dx. Okay? This is a pretty tricky one. I was kind of deliberating whether or not I should ask you this question, but I said, why not? All right, well, first of all, I want you to understand this. H is constantly changing, right? At this point, they're this far apart. But if I scoot over here to this X value, right? If I scoot over this way, now they're this far apart. If I scoot over a little further, now they're this far apart. And so H is getting smaller and smaller as I work my way this way. Actually, it starts here. So it starts at nothing, and then it starts to get wider, 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 until we get to here, and then they start to get closer together again. So the distance between them is closing. Okay, so what are you guys going to need help with here? You're going to basically need help finding out what the H function is, because they're telling you the 2 lines. They're telling you the green line, My guess is it's probably going to be the g function. And then they're also telling you the h function. Okay? Now, how can you tell which one it is? Well, when you put them in your graphing calculator, you can tell because you'll see it when you graph it, which one it is. So when you graph this one, if it looks like that, then that's the pink one. If you graph this guy and it looks like this, then it's probably, that's the green one. So anyway, but make sure, because I'm guessing that this is the pink one and this is the green one. Now the reason that matters, which one is which, is because of what we're trying to do. We're being asked to find what again? We're being asked to find dh dx, so the rate of change of h with respect to x when x equals 1.8. Okay, so the first thing that should make you wonder here is, well, where the heck is h? They don't give me an h function, so how can I find the derivative of it so I can plug in 1.8? That's the part that you guys need help with, and that's what this video is for. I'm going to show you where you can get the h function from. Okay, so let's say I had f of x equals, I don't know, negative x squared plus 4, and let's say I had g of x is equal to x. I will say 2x. Why not? All right. So I'm going to graph these really quick. Because I need to know which one is which, right? That's part of the task, is picking out what they are. By the way, if you want your screen to go back to normal, you can reset everything with second plus 712, and it resets it to square one again. So we're ready fresh. So I'm going to go ahead and type in negative x squared plus 4, and g of x is 2x. I'm going to graph it. So I'm graphing both. Now I think because of your guys' knowledge of Algebra 2 and Algebra 1, you know which one is which. But let's pretend for a second that you don't. Go ahead and push trace. And now look up in the corner. It says y1 is negative x squared plus 4. Look at the dot. Which curve is the dot moving on right now? That's x squared plus 4. So now I know that it's the curving one that is negative x squared plus 4. If I push down, it jumps the cursor to the other function. And now as I scroll along, now I'm moving along the straight line, and now that means I'm on the line 2x. So now I know the straight line is 2x, and the curving line is the negative x squared plus 4. So we're looking at something like this right now, right? I think that's what it is. And we know that the curving one is the negative x squared plus 4. Okay. Now, why does that matter? Well, we're trying to find a function that represents the distance from this function to this one. In other words, how far apart are they? Well, let's think of a number line. Let's say Bob is standing here at 5, and let's say that Sue is standing here at 20. How far apart are they? Well, you being calculus kids probably got the answer pretty fast. It's 15. How did you get it? What did you do? Well, you subtracted it, right? You did 20 minus 5. That's how you can find the distance between two things. So how can I find the distance between these two functions? Well, just subtract them. Okay, so I'll call this h. So that means the distance, which I'm going to call h, is this function minus this function. Now a question should be coming up in your head. Mr. Bailey, how do you know which one comes first? Is it f minus g or g minus f? Well, come back to your number line. Which one did you do first? You did 20, right? Because it's bigger. Same thing here. Which one is higher up? It's the green line, so that one goes here. So the higher function comes first minus the lower function. Okay? So h is f of x minus g of x, which means that h is, what's f of x? Negative x squared plus 4 minus, I'll use parentheses here, 2x. And there's your function. Okay? So this is the distance between those functions. And as x goes along, that distance changes. It gets shorter and shorter and shorter until they just meet at a point and the distance between them is 0. Now the question is, suppose I were to ask you, find me the rate of change of h when x equals 0, let's say. How fast is the distance between those two functions changing when x equals 0? Well, that's just a fancy way of saying what is the rate of change of h with respect to x when x equals 0. In other words, we want to find the derivative and plug in 0, right? But we're not going to do it by hand. This is another calculator problem. I'm pretty sure it says that, right? Did I write that? It's not there. It is a calculator question, I guarantee you. When you see these ugly types of equations, those are calculator equations. All right, so what I'm going to do now then is I'm going to have to graph my new h function. So let's go back and I'm going to type in the h function. All right. So now I'm going to type in the h function. I got rid of the other two. Let's type in my h function. So for me, my h function is going to be negative x squared. I guess I'll put it in parentheses. I don't really need to, but I know that when you guys do this, you'll need to. Minus parentheses 2x. Okay, so there's my h function. That's a function that represents the distance between those two lines. Looks a lot like the other one I had, right? But that's a different one. All right, so now I'm going to find what is the rate of change of that function with respect to x when x equals 0. So we do our derivative. Second, calc 6, 0. And there it is. It's negative 2. Now yours probably won't come out to be a nice answer like that. Yours will probably come out to be some weird funky decimal. Just remember, it's 3 significant figures, or three numbers after the decimal, the thousandth place. So what did we have to do here? Well, I taught you guys basically that when you're doing this problem here, they said that we are in the region of S, so it's going to be whatever this function is minus this function that represents the distance between them. And once you create that difference function, you're going to find the derivative of that with respect to x at that value of x. And that will tell you the rate at which the distance is changing. This is crazy stuff. This is a very hard one. So are you feeling icky right now? Kind of like, what the heck? Don't worry. It's okay. You will start to feel more comfortable later. This is honestly a question that really shouldn't even be asked until like March. Okay, but you guys do have enough stuff in place to kind of start getting a grasp of it, so I thought it was worth putting it on there. So don't feel bad, okay, about not getting this, but do your best to do these 5 things every time. So there's your helpful hint video. We'll see you guys Monday. Make sure you have all 3 FRQs ready on one piece of paper.